Today we're going to be watching the most amazing science experiments that I could find in about 20 minutes.
I'm here at the Navy's indoor ocean at Carter Rock. This is the biggest wave pool in the world, and they can make all kinds of different waves so they can test, scale ships, and make them better before they actually go out on the open ocean.
You know, just off rip of seeing this thing, I kinda want to jump into it. I think genuinely I must be one of the most stupid people on the planet if that's my immediate response to seeing this thing.
I came in and I'd seen some pictures, but I just walked in here and it's insane. Because they say indoor ocean, but like, it's exactly what it is. The water even looks ocean colored. You know, it doesn't look like a swimming pool. This looks like an ocean. It looks like a test facility. It is huge.
It is 360 feet long.
You see that? That is insane. Honestly, it looks like they test like the nastiest, scariest ships you've ever seen in there. Like, I could only imagine what that looks like when they turn it all the way up. I really hope they show what this looks like when they turn it all the way to the max. I would just imagine that the whole facility just starts breaking apart until it just becomes its own natural abyss, like some Spider-Man 2 shit.
240 feet long in that dimension. It's 20 feet deep, just about the size of a football field out there. The dome above us was the largest freestanding dome for a while.
Largest freestanding dome in the world.
Yep.
What?
In this pool, they can make waves of all shapes and sizes using huge paddles that line two walls of the pool.
We have 216 individual wave makers. We can make waves from negative 45 degrees up to 135 degrees, which is kind of coming right back at it.
There are lots of wave pools in the world, but what makes this one different is control. You can create waves of a specific amplitude and frequency and do so repeatedly.
Should we try a 1 hertz?
Yeah. Do me a favor and dial up 1 hertz.
These guys are insane, man. How did they come up with this? Like, yeah, bro, we got all this set up on redstone switches. We don't need any other testing facility besides this one because we can control every inch of a wave in this room. Yeah, that's right. I can control every cubic inch of this water.
Because we're at 0.6, we'll go to 0.5, so it'll be a 2-second wave.
Here, I'm split screening waves with frequencies of 0.67, 0.5, and 0.33 hertz, all with the same amplitude. So, two things to notice. Even though they all have the same amplitude, the ones with higher frequency look like they have a greater amplitude because the slope of the waves is...
They control these things like they're sound waves. That is crazy, man. What the hell are they developing in here, man?
They've timed it so that all the waves meet up at exactly the same time and place in the pool, and this causes the wave to break. The ocean engineers can do this again and again in exactly the same way, thanks to their precise control over the waves.
Yeah, dude, we can create the exact same wave, the exact same way, every single time. It should not be possible to be able to make a wave the exact same every single time. Science is a little too pog, if you ask me.
Now, the real purpose of this facility is not to play with toys or make perfect, unnatural waves. It is to replicate on a small scale the types of waves Navy ships will encounter in the oceans of the world. Research engineers place ships modeled after billion-dollar vessels in the water to see how different designs actually behave in real-world conditions.
Right now, this is coming from 45 degrees. It's going to be about a 5-inch.
Research engineers get to play with toys all day. That's what it sounds like. Man, if I would have known that being a research engineer means that you get to play with toys all day, I would have signed up for that ages ago. It's kind of crap that they only show us these little dinky ships, because, like, I want to see a big ship get tested in here, man. Throw that thing around. Let's break it.
Now, not all the models tested here can be remote controlled.
So on the carriage is where we're going to do captive model tests, where you could tether, put power and instrumentation onto a model that can't hold it itself. So usually the model will go in this moon bay right here.
The models are hooked up here, and then the whole lab...
Dude, what's down there? A freaking Rancor? So, I feel like for this next one, I really shouldn't have to tell you guys, but don't do this at home. Don't do it.
This is the world's largest 3D metal printer. It was built by Relativity Space, a startup that aims to print an entire rocket, including fuel tanks and rocket engines, in just 60 days.
I'm like looking inside a 3D printed rocket that is actually going to go to space. This giant hunk of metal. It's unbelievable.
This video is sponsored by Omaze, offering you the chance to win a trip to space. More about that at the end of the show.
There's a lot of UV coming off the welds. You can film it, but don't look directly at it.
You get sunburned fast, so it's like you're suiting up to go in a volcano.
All right, we're gonna go in to the 3D printer and see how it works.
So that's the wire melting.
Man, that's satisfying, isn't it? Hey you, what are you doing in my YouTube video? What are you doing here?
They built that like an aerospace thing, and they've had to spin up all these custom tooling designs and validate that those work before it actually starts building the rocket. And they've finally got one being assembled on the pad after 11 years of development.
Yo, this man Scott looks like a Scottish version of Mr. Clean, and it's awesome.
So this is the actual rocket tank structure of what we're going to be launching to orbit at the end of this year. So this actual thing is launching to space.
That will go to space.
This will go to space, and it's by far the largest 3D printed product really of any type ever made that's gonna fly. I think maybe of any type in the world.
But it still looks 3D printed, like you can still see the layers.
Yeah,
right?
you can still see the layers. It only adds an extra 5 to 10% of the mass with the roughness. When you actually cross-section the material and look at the machine parts of it, it looks like normal metal. Like actually at this end, this is printed as well. We just machine it afterwards. So it looks like normal metal in the joint sections.
So I guess it does make sense that you would want to 3D print these rockets, because you can make them exactly the same every single time and just inspect them afterwards, make sure there are no defects, and then do all the man-made stuff like that guy was just talking about. Easy peasy, right? Now this next video we're gonna watch is one by Mark Rober, and if you don't know who he is, I don't even know how you ended up on my channel. If you don't know who Mark Rober is, you should definitely go check out his channel. I'll definitely link him below. He is absolutely spectacular. That said, let's go. Let's check this man out.
This is space, and this is an egg moments before I attempted the world's highest egg drop. Now in an egg drop competition, in case you never had the chance to do it yourself in school, the goal is to build a contraption that can protect a raw egg from breaking when dropped from the tallest height possible.
I don't think I ever got to do that as a kid. I don't recall it. Have you guys ever done that?
I was thinking. The plan was to clamp an egg to the front of a rocket, then attach that rocket to a weather balloon and take it up to space. Once there, the weather balloon would release it, and just by using gravity only, the rocket would eventually accelerate past Mach 1, breaking the speed of sound, and then it would autonomously adjust the 4 fins on the back to steer itself to the target location, and then at 300 feet above the ground, it would release the egg, which would free fall onto a mattress that we'd placed on the ground. And that all seemed pretty straightforward. So like any good engineers would, we broke the problem down into smaller steps, starting first with calculating the terminal velocity of an egg. And by terminal velocity, I mean that any
Don't you do that? Don't you just casually calculate the terminal velocity of an egg? I mean, that's what we do on a Tuesday, don't you?
So to make sure the egg wouldn't break if we dropped it onto a mattress at its terminal velocity, we ran our first test. And since we couldn't find a tall enough building whose lawyers would agree to let us hurl an egg off the side and onto a mattress, we had to improvise a bit.
That's one of those things where it's like, you know, once you see it, it's like, damn, I never knew I needed that in my life. I need an egg catapult, don't you?
Yes! Check the egg! No cracks. So our mattress will protect an egg even if it's traveling faster than its terminal velocity. That's a good start. The next step in our DIY space program was to head back to my friends in the small farming town of Gridley, California, where the plan was to set out a target mattress for the egg to land on in the middle of a field.
All right, so we've got the smoke charge back here so that as we're like coming down from the sky, we want to be able to pick it out. This is the computer, here's the fins.
This, by the way, is Joe, and he has a fascinating channel called BPS Space. And what makes him especially cool is he didn't go to school for any kind of engineering degree. He's all self-taught and recently even landed a launched rocket SpaceX style after 7 years of trying. Joe was in charge of tracking and
Dude, that guy's badass.
the rocket to the mattress using these movable tail fins, whereas I was in charge of the payload. In other words, how we would keep the egg from freezing on the way up in a little oven with heaters which would break away before we dropped, along with the mechanisms to release the egg itself. Basically, before we spent all the time and money taking the balloon all the way up to space, we were here just to do a low altitude test at 10,000 feet, just to prove to ourselves we could steer the rocket using the fins.
We're setting all sorts of world records out here. World's largest mattress, fastest egg,
Yep.
tallest egg drop. What could possibly go wrong?
Okay. No!
I don't think he's down for this, dude.
Precious egg. In the history of our universe, this is the first chicken that's ever laid an egg that will go faster than the speed of sound. Supersonic. Mach 1.
I feel like maybe that's a little bit unneeded. You could have just taken any regular, unfertilized egg. That would have sufficed. But the man Mark Rober, he's got to do the whole process. He can't leave anything undone. No, seriously though, much love to Mark Rober. He's insane.
And so after all the requisite last-minute preparations and 3 long years,
Here we go, girl.
it was finally time for liftoff.
Ready? 3, 2,
I mean, it
1.
really is spectacular, isn't it?
And everything was looking good. The balloon ascent rate was just what we predicted, and that meant we for sure didn't have a leak, and things were finally breaking our way.
Is that how it's supposed to look?
So once the balloon hit 30,000 feet, we decided to hop in the car so we could drive over to the predicted landing spot.
We've passed some critical threshold points, and we're still in the game.
And we eventually started outrunning the balloon in the car, so we pulled over for a bit as we reached an important altitude milestone of 100,000 feet.
I would say over 100.
Over 100.
That's 19 miles up and 2.5 times higher than a typical commercial plane flies. And because the balloon expands so large as it rises, we realized we could actually even spot it from the ground, which was awesome.
Yeah, no, I see it, yeah.
Dude, that's totally it.
What wasn't awesome was when moments later Joe, while looking through the binoculars, made this gut-wrenching observation.
It dropped within the last 2 minutes.
Yeah.
That's 30,000 feet over the last however, so it's just popped.
But these don't pop. There's zero pressure.
And that's true, they don't pop. But unbeknownst to us, while we were looking at it from the ground, the rocket and beach ball had been spinning around and around. This meant the cord that attaches to the string that self-destructs the balloon was getting wrapped around tighter and tighter until it was so tight, it pulled down on the balloon string that is designed to essentially unzip and destroy itself. It all started coming down in one big tangled heap at 150 miles per hour, which is way faster than the eggs could survive.
Oh, well, let's start driving.
This was our Apollo 13 moment. If our payload could autonomously jettison itself from the tangled rocket balloon mess at 20,000 feet, then it would be able to deploy our lucky orange parachute and land the eggs safely on its airbags. There was nothing left to do but go on a hunt to find the wreckage and reveal our fate.
I see something orange. That looks like a rover parachute.
You see, what I tell you guys, Mark Rober, he's literally smart enough to almost send an egg into space.
We've got a thing?
And seeing the payload all by itself was a huge deal, because it meant it had actually autonomously ejected itself from the mangled weather balloon mess at 20,000 feet. And later when we checked the footage, this is exactly what it confirmed. And
At least his emergency mechanisms didn't fail on him.
while that was incredible news, I knew by this point not to get my hopes up.
I mean, so let's look through the window, a little bit of dirt. You see.
Good, definitely touchdown, but
Touchdown confirmed. Whether or not we're safe on Earth is TBD, right?
let's check it out to be sure.
Oh man.
Touchdown confirmed. We're safe
Nice.
on Earth.
We're safe on Earth!
The egg is safe!
That is a hot egg! It was in space and now it's on Earth and it's not broken.
But you know his breakfast the next day was out of this world.
Oh, brother, this guy stinks!
Oh my God. Look at that. Touchdown confirmed. Look at that. We're safe on Earth.
We are safe on Earth!
Well, that's it. Thank you guys for tuning in. I hope you guys enjoyed today's video. If you did make it this far into the video, you're Pog. If there's just one more thing I could ask of you,
All I ever wanted was thumbs up from Poppy.